Okay, next problem. Letter B, that is 1.50 liters of chlorine at 750 millimeters of mercury and 20 degrees Celsius from molten sodium chloride. So we have volume, you have your pressure and your temperature. So still PV nRT, we still plug that PV is equal to nRT or the number of Cl2. The number of Cl2, Cl2 is the gas. So the number of moles of Cl2, we just copy the last problem, the formula that is a PV all over RT. So this is for number of moles of chlorine. We substitute the given that is 1.50 liters. So that is 1.50 liters for your volume. How about for your pressure? Sorry, that is 750 millimeters of mercury. So 750 mmHg. So that is millimeters of mercury. Your R is a constant 0.08205666 liter ATM per mole, and then Kelvin, and then I guess your temperature is also given. That is 20 degrees Celsius. So that should be 20 plus 273 0.15. So that equals 293.15 Kelvin. So now conversion factor, this liter is already cancelled off. Your Kelvin is already cancelled off. Then your millimeters of mercury, you can look from your tables, that is 760 mmHg is equal to 1 atm. So that is for pressure. So cancel ang atm, cancel yung millimeters mercury. So what remains is the mole. So this is the number of moles of chlorine gas. But how about for every chlorine gas, what is how many mole of electron does it need? So we just have to go back to your table of ions that your chlorine from your molten sodium chloride, your sodium chloride molten means from your KSP or solubility products, that is sodium and chloride. Okay, so that is sodium and chloride, and then this chloride here will form the chlorine gas. Again, you'll be the one you will supply this. Okay, so you need two of this, and then you see that you need how many electrons would be needing. That would be two electrons is needed. Sorry, two electrons. Sorry, 2 mole of electron is actually sorry, 2 mole of electrons would be needed here, or it just means as you produce chlorine gas. Um, how about the last one? I think the last one, what we have, why is the electrons showing at the left? Oxygen oxide. So I think amo gyapon. Anyway, the only thing that we need is we need two moles of electrons. 2 moles of electrons for that chlorine gas. For that oxidation reaction. Oxidation reduction that will happen. You need 2 electrons for that. Anyway. So, siguro sa pag-represent, hindi ko yung butang. So, mga negative. So, ading yung dapat hindi ha. Right side if you want your Cl2. Ang imo oxygen kanina, may I correct. May I correct it. So, that would be an oxide, -2, and then it forms O2. So, if you have a -2 here, you put 2 oxygen here. So, that's a -4. I would put a 4 electrons here. So, 4 electrons um, for the transference or making that O2 molecule. So that's what is needed for mole of electron. Here, we have 2 mole of electron that is needed. So for every, so ini nga mole nimo chlorine, makatunig mo ha? So for every mole of chlorine, for every 1 mole of Cl2, you need 2 mole 2 mole of electron. So cancel adding a mole, cancel adding a mole. Thereby having your final answer, which is, di ba? Haigbaw, that would be you have 750, then you would have a 1.50, then you would have a 2 mole electron. So how about at the bottom? You need 0.0.082056. So no units now, and then you have your 293.15 plus 20 siya, and then multiplied by 760. So that is all in all. So you have 750 times 1.50 times 2. Lower part is 0.082056 times 293.15 times 760. So that equals to 0.123 or 0.12. 0.123, that is mole of electron. Okay, so we have to cut.